Welcome to our first proof in the series on the algebraic limit theorem. Today we are going to prove that a sequence times some constant c approaches its original limit times some constant c. Let's first take a look at the original limit. Because we assume that our sequence converges towards some constant a, we can choose epsilon and n such that all items in the sequence after the nth item are closer to a than epsilon. So again, we can choose some constant n and some constant epsilon, and all items in the sequence after the nth item are closer to a than epsilon, since they are closer to the constant a than some distance epsilon. So we may multiply any positive number onto epsilon, but because epsilon is some arbitrary positive number, we may multiply any positive number onto it. We can basically say, well, epsilon may also be expressed in some term epsilon 0 divided by, say, c, right? And this is what we do here. This is okay because we can still make this number here arbitrarily small. This is why it's okay to divide or multiply some positive number onto epsilon. Now we plug our new sequence and limit into the definition, and by new I mean the one up here. We factor out c and realize that our new choice for epsilon works out perfectly if we just multiply this side by c as well. Okay, we divided by c when we chose epsilon, and we now multiply by c because we have this c here, right? And this was, we just shown, okay, if the sequence converges, we can choose epsilon divided by c just as well as any other epsilon. And we show, oh, we can also multiply both sides by c, and we get that our choice of epsilon was actually arbitrary and everything worked out perfectly.